Hey guys, in this video we're going to be talking a little bit more about blood spatter and things that they look for to recreate the crime scene. Um, so the patterns left by falling, projected, or smeared blood can be used to interpret and reconstruct what happened at a crime scene. So a lot of times these can be used to prove or disprove a suspect's account of what happened, because we can trace back where blood drops came from, what caused those blood drops to form, things like that. Observation of the position and shape of patterns can be used to find the direction of travel, angle of impact, position of origin, and the speed of impact. Yet again, all to help recreate the crime. How to describe bloodstains. We're kind of going to go through a series of different things they look at. This was a list in your book that is alphabetical, so some things may relate to a later term that we'll come back to. One thing that they look at is angle of impact, and this is one thing that you're going to be calculating in our activities. It looks at the acute angle formed between the direction of the blood drop and the plane of a surface it strikes. So by the shape of the blood drop, you can actually tell what angle it hit at and where it came from. So that's the image in the bottom left. As you'll notice, as that angle gets smaller, the blood drop starts elongating. Excuse me, I have a cold. Then you might have something like arterial spurting patterns. This is a bloodstain pattern resulting from blood exiting the body under pressure from a breached artery. So it will not be a constant spray. It will spray and stop, forming a very wide broken pattern like the middle image. With head wounds, especially with gunshots, things like that, we end up with a back spatter. This is blood directed back towards the source of energy or force that caused the spatter. So if someone shoots another person, blood will squirt back at the shooter. So a lot of times this is where the shooter will actually have blood from the victim on them from that back spatter. Blood spatter analysis is just the entire field of forensics that deals with the physical properties of blood and the patterns produced under different conditions as a result of forces applied to the source of blood. So using blood spatter analysis, a lot of times they can tell if the assailant was right or left-handed, what type of weapon they used. They may be able to tell if there was a second assailant, things like that. Blood stains are evidence that liquid blood was in contact with any type of surface. And then we have cast-off patterns. These are blood stains created when blood is released or thrown from a moving object that is covered in blood. So the images below show some of the different cast-off patterns you might have. So the image in the bottom left shows how it happens. We have a hammer that strikes blood. You have some back spatter and forward spatter on the walls or areas. Well, when the hammer is pulled back, some of that blood gets flung off of it, creating a cast-off stain. The cast-off stains will have different shapes depending on the weapons used. So in our image in the middle, if you notice, we have a pipe and a pool cue. Both are cylindrical in shape. The pipe tends to be thicker, so it results in larger blood drops than the pool cue, which will have smaller drops. Whereas if they're using something like a knife that's very thin, it'll result more in the image on the right, where the droplets are more stringy. We have contact stains, which are blood deposited from direct contact between two surfaces, one of which is bloody. So someone steps in blood, and as they walk, they're transferring and leaving behind that bloody footprint the entire way. We look at direction of flight or direction of travel. This is the trajectory of the blood drop which can be established by looking at its angle of impact and its directionality angle. One thing that you'll notice a lot of times is blood drops will have tails on them. And that tail shows you where the blood drop was traveling to. So it's almost like an arrow pointing in the direction of travel. Whereas directionality just indicates the direction that blood was traveling whenever it hit the surface, but it does not include that angle of impact. So that's the difference between direction of flight and directionality. And directionality can be found simply using the geometric shape of the blood stain. If it is dropped straight down, it is going to be more circular, versus if a blood drop comes in at an angle, it will have that elongated tail indicating the direction of travel. The directionality angle is the angle between the long axis of the blood stain and the predetermined line on the plane of the target surface that represents 0 degrees. So this is going to be very similar to that angle of impact overall, but it's actually measuring not the angle that it flew in from, but the length of the actual blood drop itself. We have a drawback effect. This is especially in shootings because whenever someone shoots a weapon, after the bullet is fired, air is sucked back into the barrel. Well, a lot of times blood will get sucked back into the barrel of the weapon as well. So even if someone tries to clean the weapon, they don't think to clean inside of it, so there will still be traces of blood on the weapon themselves. We also have drip patterns. These are patterns resulting from blood dripping into blood. So here we have a drip pattern, and you can almost tell which blood drop came first by their interactions. So the one that tends to be most spread out is the one on the bottom. That one occurred first. Whenever the top blood drop connected with that one, you got more spray and more spread out. And the one on the right is our last blood drop. Whenever it dropped, it caused other spatter, but it is not interfered with like the other drops are. We also end up with expirated blood. This is blood that's actually blown or forced out of the body. It could be out of the nose, mouth, or wound as a result of air pressure or airflow. So if you have a bloody nose and you try to blow it out, that is considered expirated blood. If you bust your lip and you spit out blood, that's also considered expirated blood. We have flight path, which is simply the path of the blood drop moving through space from the impact site to the target. So actually mapping out how the blood drop got from one area to another. And then we have flow patterns. This is where blood will change the shape and direction of the blood stain due to gravity. So especially if blood is on a wall, gravity will pull any heavier blood drops down, creating a flow downwards, and a lot of times distort the overall image of the blood stain. So we already talked about back spatter, where especially in a shooting or something, blood will go back towards the assailant. Forward spatter is blood that travels in the same direction as the source of energy of force that caused the spatter. So here we have our simulated head, and the bullet is coming from the left into the head and then exits out the back. That is that forward spatter. With blood drops, we also kind of have to look at how fast they were coming in. So we have high velocity impact spatter, which are patterns caused by high speed impact or force to a blood source, something like a gunshot. The velocity of the blood drops can be up to 100 feet per second, and drops are going to be less than or equal to 1 millimeter. So this is going to have a multitude of drops that are very small, like the picture in the right. Our impact pattern is a pattern created when blood receives a blow or force, resulting in random dispersion of blood drops. So think of if you have a puddle of water and jump in the puddle of water, it's going to spray outwards. This occurs in the same way. The impact site is the point of force where it hits the blood source. So this could be the site of any type of blunt force trauma, things like that. We talked about high velocity impact spatter. Now we're going to talk about low velocity impact spatter. This is a blood stain caused by a low speed impact or force to a blood source. So the velocity is really only up to about 5 feet per second, and the drop size is going to be 4 to 6 millimeters. So in comparison to the high velocity, it is moving slower, but you're going to have less drops, and the drops themselves are going to be larger. Then we have medium velocity impact spatter. This one is a pattern caused by a medium speed impact or force to a blood source. This a lot of times will occur with more of a beating or stabbing. Velocity can be up to 25 feet per second. So in between the low velocity and high velocity, and the individual stains or drops will be anywhere from 1 to 4 millimeters. So these will be smaller than drops with a low impact, but larger than ones with a high impact. So that's the image on the left. So if you notice, there's not as many drops as a high impact. There's less drops, but more than a low impact. But the drops are larger than a high impact, but smaller than a low impact. We also encounter misting, which is the image on the right. This is blood that has been reduced to a fine spray as a result of the energy of force applied to it. This a lot of times you'll see whenever an explosive goes off or something like that. The blood is flung at such a high speed that you can't really distinguish the individual drops. It just ends up as this mist. We have parent drops, which are blood drops that cast off a wave or satellite pattern. So these are the first blood drop that occurs, and then you may have a satellite spatter that comes off of it. So a satellite spatter is a small droplet of blood distributed around a drop or pool of blood as a result of the blood hitting the target surface. So down in the bottom left, we have a picture of this. We have a parent drop that comes in, and then it continues, and there's a secondary drop off of it. Or you may have sprays that come off of it. One thing to note is the satellite tail points in the opposite direction of the tail of the original droplet. We also end up with passive drops, which just occur from any type of regular bleeding. So these are drops created or formed by the force of gravity alone. So if you cut your finger and it's running down and dripping on the floor, that would be a passive drop. There's no force associated with it. We have the point or area of convergence. This is the point on a two-dimensional surface, so like on a floor or a wall, where the directionality of several blood drops can be traced. So this will find kind of the height on the wall or the point on the floor where the blood originated. Then we have the point or area of origin. This is more three-dimensional. So this you might see at crime scenes where they do stringing and connect all the blood drops together. So it finds the point in the three-dimensional space where the trajectory of different blood drops can be retraced. In the blood spatter reading and activity, there's actually a video that shows them finding area of convergence and area of origin. A projected blood pattern is a blood stain caused by blood released under pressure, such as arterial spurting. So this might happen especially with gunshots, anytime there's a punctured lung, something like that. It will actually blow blood out of the body itself. Spatter is any blood that's been dispersed as a result of force applied to its source. Spines are the pointed or elongated stains that radiate from a central area of a blood stain. So these are kind of going to be those rays or spatter patterns that come off. So in the image in the bottom right, you have your initial blood drop, and those little spikes that come off of it are spines. On the image on the bottom right, the far right of it, those tails can also be considered spines. We have swipe patterns, which is the transfer of blood from a moving source onto an unstained surface. So if someone gets blood on their hands and wipes the wall, that would be a swipe pattern. And the direction of travel can be determined by the feathered edge. So it will actually start off dark and then get lighter as the swipe pattern continues. That's the image on the bottom left, where you have the bloody handprints and then they swipe downwards and it ends up being lighter at the bottom. You notice that feathered edge. The target is the surface where blood is deposited. And then we have a wipe pattern, which is different from the swipe pattern, where there's a blood stain when an object moves through an existing blood stain, changing its surface. So here we had blood drops that were already on this surface. You can kind of see their outline or their halo. And then someone wiped their fingers through it. But you notice that the blood was already there, and then someone altered the appearance. We have transfer contact patterns. We already said contact patterns, but it's anything where you have a wet, bloody surface that comes in contact with a second surface. And a lot of times you can actually see the image of what left that blood stain, like a bloody footprint or a bloody handprint. These are the two images on the left. And then we have voids. This is the last one that we're going to look at. This is particularly useful because it's actually the absence of blood stains, so it means that there is an object blocking blood from reaching that area. So you end up with a shadow of the object that used to be there. So the two images on the right are both of voids. The one on top, if you look where there are no blood drops and you outline that shape, it looks like it's actually from a wrench. So there was a wrench laying there, and after the blood drops were there, the wrench was picked up and moved. In the bottom right, if you outline that image, it has two handles and then a sharp point. That's actually from a pair of scissors that were laying there and then picked up after the blood drops were left off. Things that we'll look at with blood. We look at the direction of the blood drops to figure out where they came from. You can actually find the approximate height of drop size. This is one thing that you're going to do in our blood spatter reading and activity. Generally, the higher the blood drops come from, they tend to spread out more and get bigger. One thing you need to be able to do is calculate the impact angle. This is in one of the activities. The impact angle is the arc sine, which you guys may know is the sine -1 on a calculator, of the width of the drop divided by the length of the drop. And the width should always be smaller than the length. And note that these measurements don't include any extensions, so it's just the main shape of the drop, whether it's more circular, more oval. So whenever you're typing that in the calculator, you do want to type the second sine and then do your width over your length. Make sure that they are measured in the same units. So if you're using inches, they need to both be in inches. We tend to use the metric system, so I might recommend using centimeters or millimeters. You want to find the origin of the blood drops using triangulation, so that's where we talked about them finding the area of convergence or area of origin. by using those angles of impact and actually stringing to find where those blood drops are. Remember, there's a video on that. So a piece of string might be attached to each blood drop and then see where they connect to find that area of origin. And a lot of times you can figure out if the assailant was right or left-handed based off of the pattern of the blood drops, where they were initiated and then where the cast off patterns and things are. That can help narrow down your suspect pool. Make sure to try out the blood spatter reading and calculating angle of impact.